Hello, my name is Mr. Asbury and this is my Edexcel IGCSE exam questions series. I split the whole IGCSE up into 60 topics and this is number 54, completing the square. So these are lots of exam questions on completing the square. It's the second series, so I've done a series 1, so if you want to check that out, link down below. Okay, so let's go, 54, completing the square. Okay, so before I start, any quadratic can be written as ax squared plus bx plus c, like this. Let me first refer to the quadratics where a term is 1, so it's just x squared plus bx plus c. We can complete the square by using this technique where we focus on the b term, the number of x's. And essentially what I'm going to be doing is I'll write down what the b term equals, then I'll write down what b divided by 2 is, and then I'll write down what b over 2 is all squared. I'll do that because if to complete the square, all I need to do is write x plus that b over 2 term inside a bracket squared, minus whatever that b over 2 term is squared, and then add on the c term which is left over. Okay, so perfect. Let's look at this example here then. So we've got minus 10 is our b term. So I'll write that over here, minus 10. I'll then half it, minus 5. And then when I square that value, minus 5 times minus 5 is 25. Okay, so I've got all of the pieces now. And I can just write that x squared minus 10x plus 40 is equal to, open brackets, x, and then what is this plus a half b? Well, it's minus 5. Okay, so I can just write inside that bracket minus 5 squared. And then I'm taking away this b over 2 all squared term, which is 25. So I need to take that away. Okay, so I write take away 25, and then plus on the c term, which is 40. Great, so we have x minus 5 all squared, and then we add these two together, that gives us plus 15. Okay, job done. Right, we can move on to the next question now. Okay, which is a bit more challenging because there is a value for a, which means that we don't have just an x squared term. But never fear, what we can do is we can factorise out the a term. So taking out the 4, I'll do a big square bracket like this, and I write x squared, and if I take out the 4 from the minus 8, that gives me minus 2. And preference, but I don't take out the factor from the constant term at the end. So I just close the brackets early and write plus 7 in this case. Okay, so now we're going to focus on completing the square of the square bracket. Okay, so this part. So what is the b term here? Well, b term is the number of x's, which is minus 2. So then I do b divided by 2, which is minus 1, and then I square that, which gives me 1, because minus 1 times minus 1 is 1. Okay, so now I can go ahead and complete the square inside these big square brackets. So I write x, and then it's the b over 2 term, so that's minus 1 squared, and then always take away, and then the b over 2 all squared term, which is 1. Close brackets, because there's no c term to add on, because this is just a 2-term quadratic. There is no constant term there to add on. The constant term, in fact, is outside, like that. Okay, now we're going to multiply the 4 into both the bracket and also that number there, the minus 1. So I'm just going to get 4 lots of the bracket. It's the only way I can simplify that. And then I'm going to get minus 4, because that's 4 times minus 1. And then I'm going to get plus 7 as well from outside. So overall I get 4 lots of x minus 1 squared, and then plus 3, because minus 4 plus 7 is plus 3. Bosh. Okay, right, we're back at it again. Same thing, we've not got an x squared, we've got 3x squared, which means I'm going to need to take out a factor of 3. So I'm going to do a big square bracket, and I'm going to take out a factor of 3, and I'm going to do that for the 12x as well, which is going to give me 4x, and then I'm just going to leave the 19 outside. Okay, perfect. So then we're just going to focus on inside this square bracket and completing this square here. Okay, so we're going to write b term is 4, b over 2 term is 2, and b over 2 all squared is 2 squared, which is 4. Okay, so I'm going to write 3 big square bracket, and then I'm going to complete this square. So I'm going to do that by writing x plus the b over 2 term, which is 2, all squared, always take away, and then the b over 2 term, all squared term, which is 4. Perfect. And the c term was outside of the bracket, so we're good. And then I'm going to multiply the 3 by that bracket, and I'm going to multiply the 3 by the negative 4 as well. So that will give me 3 lots of the bracket, and then minus 12, and the plus 19 is still there. So overall, when I simplify, I get plus 7. Brilliant. Okay, right, straight on to the next one. Okay, very similar, but a bit trickier because we've got a minus 3x squared here. So the first thing I'm going to do is I'm going to just write it in this order so that the powers descend, because that's just what I'm used to. Okay, now what have I got to take it out to get to the 1x squared? I've got to take out a minus 3. So that's just going to give me an x squared there. I'll be very careful here because I'm taking out a minus 3. I'm going to need that to be minus 4x inside. And then I just leave the 7 outside again, just like I've been doing. Okay, so I write the b term of this 2-term quadratic here is minus 4. So the b term halved is minus 2, and then the b term halved and all squared is minus 2 times minus 2, which is 4. Great. So I can write minus 3 big square bracket, and then I can complete the square of this yellow 2-term quadratic. I get x minus half of the b term, or add half the b term, which is a negative, so I'm taking it away, squared, and then always subtract there b over 2 all squared, which is 4. Okay, and then plus the 7. Multiply out the big square bracket, gives me minus 3x minus 2 all squared, plus 12, because 2 negatives make a positive, and plus 7 as well. Okay, and that's going to be 19, and I've just noticed that they want the constant term first, so it's going to be 19, I'm going to write it first, and then minus 3 lots of x minus 2 all squared, like so. Okay, beautiful. Okay, so now it says that the curve C has this equation and it has a maximum point. Use your answer to part A to write down the coordinates of A. Okay, so just to double check, the thing that we completed the square is exactly the same as the equation of this curve, as you kind of would expect. Okay, so this is a negative quadratic, so it's going to have this shape to it, and there will be a maximum point there at the top of the curve. Now, when it's written like this, not much chance of working out what the maximum point is just by looking at it. But if it's in completed the square form, then it is easy to work out where the maximum point is. So if I look at this part, this square bracket here, now this square bracket, because it's a square, the smallest possible value it could take after it's been squared is 0, because if you square any number it will always be positive or 0, because if you've got a negative you square it, you're going to get a positive, and if you've got a positive you square it, you're going to get a positive. So if we want to find the maximum point, we want to take away as little as possible, because we're taking away this square bracket. So we want to take away the smallest we possibly can to maximize this value for y. So the smallest that the blue square can be is 0, and x equals 2 makes the blue square 0. And when the blue square is 0, the y value is just 19 minus 0, which is just 19. So we get 2 and we get 19. This also happens for minimum points as well. If you have a quadratic incomplete into square form that looked like this, for example, then that is a positive quadratic, so it has a U shape, and its minimum point in this case would be x equals 2, because you want that square bracket to be as small as possible to make the whole thing as minimum as possible. And when that square bracket is 0, the y coordinate will be 7. So just a little bit of extra knowledge for you there. Not part of the question, but you can use this same technique to find minimums. Okay, right. So first off, by writing g of x in this form, okay, so we need to complete the square on g of x, which is this here. So we're going to write g of x is equal to 2, big square bracket, x squared minus 6x, close bracket, plus 13. We're then going to look at, just like I've been doing, this 2-term quadratic, and I'm going to write that the b term is minus 6, the b over 2 term is minus 3, so the b over 2 all squared term is positive 9. We're then going to say that g of x is equal to 2 lots of big square bracket, and then we're going to complete the square for that yellow 2-term quadratic, and we're going to write x plus b over 2, so that's x plus minus 3, so x minus 3, all squared, and then always take away b over 2 all squared, which is 9, plus 13. We're going to multiply out, so 2 gets multiplied by this square bracket, and it gets also multiplied by minus 9. So we get 2x minus 3 squared, and then that is minus 5. Perfect. Okay, it says describe fully a series of transformations that map curve S to curve X. Curve S to curve T. Okay, so we start with x squared, and then it gets mapped over to this thing here. Okay, so we have y is equal to x squared, and then it changes into y is equal to 2x minus 3 squared minus 5. So most people are kind of familiar with the graph transformations when they're written in terms of f of x, like this. So what we actually got here is we are, the first thing we're doing is we're swapping x for x minus 3. So the input has become x minus 3. And then we're squaring, which is part of the original function already, because the original function is to square, it's x squared. So that's not going to do any effect. And then we're multiplying by 2, so we would write times by 2 at the front, and then we're subtracting 5, so subtract 5, like so. Now you remember from graph transformations that if you have anything inside the bracket, like this, it affects the x coordinate. And if you have anything outside, it affects the y coordinate. So that's going to affect the y, and that's going to affect the y. Okay, so how is this going to affect the x? Well, this will move it, this will translate it, and it'll be 3 to the right. Because it is x minus 3, it moves it to the right. It's a bit counterintuitive to what you expect, but whenever it's inside the bracket, it kind of does the kind of opposite of what you'd expect. But because you're minusing 3, it's actually a translation to the right. So translate 3 to the right. The multiply by 2 is going to stretch. Let me spell this right. It's going to stretch the. It's going to stretch by. So it's going to stretch in the y-axis by a scale factor of 2. So it's going to stretch it up like that. And then the last thing is you're taking away 5, which again is going to affect the y. So it's going to translate it 5 downwards. Okay, so there we have it. So we've got the first thing is the fact that it's x minus 3. That translates it 3 to the right. The 2 there, that stretches it in the y-axis by a scale factor of 2. And finally, the 3 there, that translates it 5 downwards, the minus 5. Okay, final question is a real toughie. There's a couple of ways of doing it. You could either try and complete the square using the kind of methods that we've been doing, which I think is probably trickier, or we can use a different approach, which is equating coefficients. So I'm going to do that. I'm going to try and equate coefficients. So if I want q plus 12x minus q x squared to be exactly in the form a minus b x minus c all squared, then I can make it happen. And I'm going to make it happen by expanding this side out. So I'll get a. First off, let me just do x minus c all squared over here, because x minus c all squared is x minus c times x minus c, which is x squared minus xc plus c squared. So it's x squared minus 2xc, or cx, actually probably better, plus c squared. Okay, and then I need to multiply that through by negative b. So timesing it through by negative b will give me negative bx squared positive 2bcx, because it's a negative cx there. So when I times it by negative b, it's going to become a positive. And then negative bc squared. Okay. So you might be asking, what on earth are you doing? Well, this is the equating coefficients part. Because we want these two things to be identical, it means the number of x squareds on both sides must be the same. Like so. So the number of x squareds must be the same on both sides. So that tells me right away that minus q must equal minus b. So q is equal to b. Or other way around, b is equal to q. Okay, so that tells us what the b term is. Great. So now what we can do is we can look at the x's. Okay, so there must be the same number of x's on both sides. Okay, so these are all the ones that have an x in. Okay, so if we're looking at the x's, because again, this is a quadratic, so it's definitely going to have x squareds, x's, and constants. So what we're doing is just equating each of those. So now we're looking at the x's, and we've got a 12, which is going to equal 2bc. Okay, great. So 6 is equal to BC. We know B is Q. So 6, whoops, sorry. 6 is equal to BC. We divided by 2, both sides. So 6 is equal to QC, which means that 6 over Q is equal to C. Great. So C is equal to 6 over Q, writing it that way round. And there we go, we've got what C is in terms of Q. And then the final thing to do would be to look at the constant term. So we've got Q, we've got A, and we've got minus BC squared on that side. So I can say that Q is equal to A minus BC squared. Okay, what's A? We don't know A, that's what we're trying to find. Fine. What's B? It's Q. What's C squared? It's 6 over Q all squared, which is 36 over Q squared. Okay, great. So Q is equal to A minus, and then when I times these two things together, I get 36 over Q. Add that to the other side, it gives me Q plus 36 over Q is equal to A. And that is all finished. There we go, we've got express A, B and C in terms of Q. And we've just done that, perfect. Okay, right, I hope you enjoyed that, and bye for now.